So what we see in this picture here is we see triangle ABC, and it has angle A, angle B, and angle C in it. And you see down here we have a calculation adding those angles together. 50 plus 47 plus 83 equals 180. But now let's see what happens if we change the way this triangle looks a little bit. Let me just drag the corner of this to maybe right about there. Okay, so now I change the angle measures. Now you can see I have 47, 62, and 71. And as it's changing the angle measures as I drag it around, it's updating those angle measures down here. But you can see I changed the way it looks and it still adds up to 180. So what if we change it again? What if we drag, let's make it look more as an obtuse triangle. So we have an angle in it that's bigger than 90 degrees. And you can see that even when we make it the triangle obtuse, we still have 30 plus 111 plus 39 coming out to equal 180. And so that's the first big idea that we're going to take a look at here in section 2-3. It's called the triangle sum theorem. And what it says is that if angle 1 and angle 2 and angle 3 are what we call interior angles of a triangle, then the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 will always equal 180. Or maybe another way to say that would be to say that the interior angles of a triangle always have a sum of 180. And that doesn't matter what the triangle looks like. It could be an acute triangle like the one we see in this picture here. It could be an obtuse triangle. It could be an equilateral triangle. It could be an isosceles triangle. No matter what, the three angles inside that triangle are going to always have a sum of 180. So let's put some of that to use here. Let's take a look at a couple example problems using this idea. We have to find x and y in this problem here. I see x here and I see y up here. Now in this problem what you have to realize is that there is actually three different triangles showing up in this problem. We have the large triangle and then we have the two separate smaller triangles. But for each one of those triangles, the triangle sum theorem will apply. The three angles in each triangle needs to add up to 180. So let's look at x first. And let's look at this smaller triangle here. I know that if I take x plus 96 plus 35, it needs to come out to equal 180. So now if I just combine my like terms here, that would be x plus 131 would equal 180, not 181, 180. And then if I just subtract my 131 from both sides, then x would equal 49. So x equals 49 in this picture. Let's go ahead and put that in right there. So then how can we find y right here? Well, I could do a couple different things. I could look for this angle using the fact that it's a linear pair with a 96-degree angle. All right, I could find that angle, and then I could say that these three angles need to add up to 180. Or I can say that the three angles in this large triangle need to add up to 180, and since I know that this one's 77, this one's 49, I could figure out what this angle is here, and then subtract 35 from it. I think what I'm going to do is I'm going to look at this small triangle here. So I'm going to look at this angle and I'm going to say, okay, that angle is going to be 180 minus 96, which is going to be 84. So that angle is 84. And that means that 77 plus 84 plus the y needs to come out to equal 180. Again, I'm going to combine my like terms right here. 77 plus 184 is going to give me 161. So 161 plus y equals 180. And then if I just subtract 161 from both sides, the y would have to equal 19. Now, just to show you that this would work out the same if we maybe did it a little bit differently, I'm going to kind of cordon off some space right here. I'm going to use the other method that I showed you for finding this. So what I'm going to do is I'm going to say that this plus this angle up here needs to equal 180, right? And let's just temporarily call this angle right here, let's call that z degrees. And I know that z plus 49 plus 77 needs to come out to be equal to 180. So if I combine these like terms, then I'll have z plus, I think that'll be 126 equals 180. And then if I subtract 126 from both sides, that angle z would have to equal 54 degrees. But then y plus, that would mean that the y plus the 35 would equal 54. And so if I just subtract 35 from both sides, then I would get y equals 19 that way. Just to show you that we could have done two methods. We could have used two methods to find that y equals 19. So let's come down here to example 2. Example 2, again, we see now a couple triangles, and we see an x here and a y here. Let's start out by finding x. So I'm going to look at this triangle, and I'm going to say that I know x plus 59 plus 57 needs to equal 180. Again, combine my like terms. That would be x plus 116 equals 180. And so if I subtract the 116 from both sides, that would tell me that the x would be equal to 64. So now x is now equal to 64. I'll put it on the drawing as well. And then if I look at the other triangle here, I see that I really only know it looks like I only know one angle in this triangle. So I would say, if I were trying to set up an equation right now, it would say y plus 42 plus something equals 180. And that something right here is this angle right here. But I actually can tell what goes in that box because I need to remember that vertical angles will be congruent. So if this is 64 here, I got a 64 degree angle there. So now I can put 64 in that blank. Combine my like terms, y plus 106 equals 180. Subtract the 106 from both sides, and now y equals 74. Now on this next page we see something called the triangle exterior angle theorem. So let's first just talk real quick about what exterior angles would mean if we're talking about triangles. So the exterior angle of a triangle is what you get when you take one side of the triangle, like this side right here, and you extend it out past the corner. So we took this side and we kind of made it keep going from like right here on out this way, right? We extended that side out that way. And in doing so, we created this angle called angle 4. And that's considered an exterior angle. We could do the same thing on each end of this triangle. We could kind of extend, well actually let me do it this way. I'll extend this out that way, and I'll extend this out that way. And then we can see we would have created a couple more exterior angles here. Well, let's talk about what the measure of angle 4 would be equal to. And let's do that by trying to figure out, well, what relationships do we know exist in this picture between some of these angles? And the first thing we could say is that we know that the measure of angle 1 plus the measure of angle 4 would equal 180. And I know that because they're a linear pair, right? They're a pair of adjacent angles whose non-common sides are going to form this straight line, and we know that linear pairs always add up to 180. I know something else about this picture, however, too. I know that if I take the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3, that would also equal 180 because the triangle sum theorem, right? We learned that we were just talking about the fact that triangle interior angles always add up to 180. Well, now if I look at these two relationships, something should jump out at you. They both contain a measure of angle 1, and they both equal the 180. So whatever is being added to the measure of angle 1 in the two equations must have the same value, right? If I'm adding measure of angle 1 to two different things and getting the same answer, then this and this must have the same value, right? That would mean that the measure of angle 4 would equal the measure of angle 2 plus the measure of angle 3. And so if I look at that picture, here's angle 4. And then angles 2 and 3 are the inside angles that are not adjacent to angle 4. So if I were to put maybe, let's put a 5 out here, the same relationship might exist where if I add 5 to 2, I'd get 180. And if I add angles 1 and 3 to 2, I'd also get 180. And so that would mean that angle 5 would have to be the same measure of angles 1 and 3. And if I were to put an angle 6 out here, I would notice that if I add 6 to 3, I get 180. And if I add these two together and then add it to 3, I'd get 180. So 6 would have to be the same measure as these two interior angles. And so this idea is what develops into what we call the triangle exterior angle theorem. And it says this: the measure of an exterior angle of a triangle is equal to the sum of the measures of, and this is going to be a new term here, it's the sum of the measures of the two remote interior angles. And so when we say remote interior angles, we're saying that interior angles that are not directly adjacent to the exterior angle, they're remote. Remote means like far away in this sense, right? So the two interior angles that are farther away from angle 4 would be 2 and 3. Add those together, that's the measure of angle 4. The remote interior angles for 5 would be 1 and 3. Add those together, that's what angle 5 has to equal. And then for angle 6 here, the remote interior angles would be angles 1 and 2. Add those together, that's what angle 6 has to equal. So now let's see if we can put some of that to use in a couple example problems. So in this first problem, we have to find x, and x we can see is an exterior angle right here. Now, if we use that previous theorem we just learned, we would realize that this exterior angle is going to have a measure that's equal to the sum of the two remote interior angles. So the two interior angles that are not next to it. Well, that would be these two, wouldn't it? The 54 and the 57. So we would just say that x is equal to 54 plus 57. So x is equal to 111 degrees. In number 4 here, we see now that we have x as an interior angle. And what we know is we know one other interior angle. We're missing one of the interior angles, but we have this exterior angle. And we would know that that exterior angle, which is 104, would be equal to the sum of the two remote interior angles, which would be the x and the 49. So now to find the value of the x, we're going to subtract 49 from both sides, and that's going to be 55 equal to x.